Good morning, children. Welcome back to SBR online classes. So, this is the chemistry session. We have learned about in previous class. We have learned about the exercise part. Means we have solved the exercise questions. Okay. So, the chapter in the chemistry, third chapter in the chemistry is the atoms and molecules. Okay. So, today let us continue with the exercise questions. We have completed a third question yesterday, that is what are polyatomic ions along with the examples. Okay, so we have learned about what is a polyatomic ion. It is it contains more than one atoms and which behave like a single unit. Okay, and we have in the previous class sir has taught you about the ions. That is, ions is any charged particles. We are going to see two types of ion. One is a cation and another one is an anion. Okay. So today let us continue with the next question. That is the fourth question in the exercise part. Here, the question is like this. Write the chemical forming of the following. In the previous class, already have learned about how to write a chemical formulas. Okay, here they have given the few compounds, and you have to write the formula of these compounds. That is magnesium chloride, then calcium oxide, copper nitrate, next one aluminium chloride, then calcium carbonate. Okay. So in this session, let us continue with this question. That is, yesterday we have completed three questions, and today let us move to the next one. That is the fourth one. The question is like this: write the chemical formulae of the following. Here they have given a magnesium chloride, calcium oxide, copper nitrate, aluminium chloride, and the next one is the calcium carbonate. So we have to write the chemical formula. How we are going to write the chemical formula? By using the symbolic representation of the element. Okay. So here, first one. Here, magnesium chloride. Here we have learned about that is symbol for the elements like in hydrogen, helium, lithium. That is for the hydrogen H. For the helium He. Okay. So here I am going to take a just I want to tell you about the symbols for the elements. Here the hydrogen, we have to write the capital letter for the symbol for the elements. That is here the hydrogen. Here the name of the element is the hydrogen and the symbol is the capital letter H. Then next one, that is a helium. Here, the helium is the one of the element, and how to write the symbol for this helium? That is first letter He. The first letter it is going to stand. We have to write in a capital letter, and then the second letter we should write in a small letter. Okay, please keep this in your mind. That we have whenever we used to write the symbol for the elements, we have to follow this rule. That is the first letter we have to write in the capital letter, and the second letter we should write in the small letter. Okay. Some of the students they will write a He, and aluminium they will write Al. So these are the wrong way of writing the symbol for the elements. So please first letter we have to write it in the capital letter, and second letter we should write in the small letter. Okay. So here magnesium. What is the symbol for the magnesium? Mg. Capital letter M and the small letter G. Okay. And here magnesium chloride. The magnesium symbol Mg and the chloride symbol is the Cl. Here we are going to write the valency. Okay, the valency of the magnesium is the +2, and here the chloride is the -1. And what we have to do? We have to crisscross this one. Okay, what is this? This is the charge or the valency. Okay, so here we know that the magnesium it is the 12th element. Okay, sodium, magnesium. Okay, 11th element is the sodium, and the 12th one is the magnesium. Here, briefly, I will tell you about a valency. Valency means what? A combining capacity of an atom. Okay, combining capacity of the atom of the element. So here, how we are going to write the valency? How we are getting this +2 charge? Here, we know that the atomic number of the magnesium is a 12. Means here atomic number of the magnesium is 12. And for the distribution of the electrons, what we are going to take? We are going to consider this 12 number, because what is the definition of an atomic number? The number of the electrons present in the atom. Okay, so here how we are going to distribute this in the magnesium? That is the 2 electron. 12 means the total number of the electrons present in that element. Okay, in the magnesium atom. In the first orbit, the 2 electrons we have to distribute, and when we are from the 12, when we are going to distribute the 2 electrons, again how many electrons are left here? 10 electrons. So in the second orbit, we have to distribute only 8 electrons. Here total 10 electrons are there, but the capacity of the second orbit it is going to take only 8 electrons. Okay, it's going to take a less than 8 electrons, but not more than 8 electrons. So from the 10 electrons, we have to distribute the 8 electrons here in the second orbit. Okay, so 8 plus 2, 10 completed. Still, how many left here? The 2 electrons are left over. So here, again, the 2 electrons we have to distribute in the third shell. This is the first orbit, this is the second orbit, and this one is the third orbit. The remaining electron we have to distribute in the third orbit. Okay. So here, this is about a magnesium. Okay. Then for the chlorine, here the atomic number of the chlorine is a 17. Means when we are going to write the electronic configuration, when we are going to distribute the electrons, what we have to do? We are going to consider this 17 atomic number. Means the 17 electrons are present in the chlorine. Okay. So here, how we are going to distribute this 17 electrons in the first orbit? The first orbit capacity it is going to take only 2 electrons. It is going to follow the duplet rule. Okay. Then, after completion of the first orbit, what will happen? We will go the remaining electrons we have to distribute in the next orbit. So here from the 17 we have distributed the 2 electrons in the first orbit. Okay, and remaining electrons are 15 electrons are left over here. Okay, so among the 15 electrons, the second orbit is what is its capacity? Its capacity is going to take 8 electrons. Okay, it is going to follow the octet rule. Okay, so here 10 electrons are over here. When we are going to fill, when we are going to distribute the 8 electrons in the second orbit, what will happen? It will become stable. Means it is not going to take more than 8 electrons. It is going to take the less than 8 electrons, but not more than 8 electrons. Here, the first orbit it is going to follow the duplet rule, and the second orbit it is going to follow the octet rule. Okay. Then the remaining 7 electrons that we have to distribute in the next shell. That is the third one. Okay. Here the 7 electrons, when we are going to distribute in the third shell, what will happen? To attain the stability, to attain the octet rule, what will happen? It is going to need one more electron. Okay. So here to attain the stability, to become stable, here this required one more electron. Okay. So here when you are going to see a magnesium in the outermost orbit, 2 electrons are there here. And here the chlorine, one chlorine atom is going to require only 1 electron to attain the stability, to fulfill the, that is octet rule. Okay. But here in the magnesium, 2 electrons are there. What it will do? It is going to donate the electrons, 1 electron to the one chlorine atom, and the next one it is going to donate to the another chlorine atom. Okay. So when it is going to donate the electron to the 2 chlorine atom, here the first chlorine atom it will become unstable, and the second chlorine atom it will also attain the stability. So here this plus 2, what it is going to indicate? The plus means it is not going to gain the electrons. It is the plus charge is going to indicate it is going to lose. It is going to lose the 2 electrons. Okay. So here the chlorine, what will happen? It is going to get the 1 electron from the magnesium. Okay. So here this is the valency or the charge of the magnesium. Means it is going to lose the 2 electrons, it is going to gain the 1 electrons. Okay, this charge we have to crisscross here. This plus 2 it will goes for the chlorine, and this minus 1 is going to go for the magnesium. So here how we are going to write the formula of the magnesium chloride? That is formula. It comes like this. Here we have to write like this: MgCl2. Okay. So MgCl2. Here 1 is there. Nothing means it is understood 1. So we need not to write this 1. And this 2 it will go for the chlorine. Okay. And it will become a chloride. Okay. So MgCl2. This is the formula, chemical formula for the, stand for the magnesium chloride. Okay, then go to the next one, that is calcium oxide. What is the symbolic representation for the calcium? Ca. Okay, and Here the charge for the calcium +2 and for the oxygen, that is -2. Again, what we have to do? This is the symbol, valency or the charge you can write, then formula. Okay, these charges or this valency we have to crisscross. Okay, this is the rule for writing the chemical formula. Okay, so +2 -2 it will become cancel. Okay, we need not to write like this Ca2 and O2. Okay, this is the wrong way of writing the formula. What will happen here? The charges is going to cancel. So CaO is for the right symbolic representation for the chemical formula for the calcium oxide. Okay, then next copper nitrate. Okay, so here symbol for the copper and the nitrate, it is a polyatomic ion. Yesterday we have learned about the polyatomic ion. That is that here it is having the charge which behave like as in a single unit. This is a polyatomic ion. Okay, so here the charge of this copper is a +2 and this polyatomic ion it is -1. Again, what we have to do? We have to crisscross this valency or the charge. Okay, then formula, how we are going to write the formula? CuNO3. This for the polyatomic, when it's going to have the same charge, what we are going to do? We are going to use the bracket for this polyatomic ion. So here we are going to be using this bracket for this polyatomic ion. So CuNO3 2. So this is the chemical formula for the copper nitrate. Then next one, aluminium chloride. Here symbol capital letter A and L. Okay, some of the students, again I am telling you, don't write both the letters that is in the capital letters. Okay, and charge of this here is the +3 and here is a -1. According to the rule, what we have to do? We have to crisscross this one, and the formula is like this: AlCl3. Okay, so for the copper nitrate, CuNO3 2, and here for the aluminum chloride, AlCl3. Here we need not to write the bracket for this. It is a single ion. Okay, it is a single. Here for the polyatomic ion, we are going to use the bracket here. Then next one, calcium carbonate. About the valency, in the next chapter you are going to learn in detail. Okay, that is the 4th chapter, structure of the atom. Okay, here calcium carbonate, a symbolic representation for the calcium is Ca, and for the carbonate CO3. Here don't write a small letter O. Some of the students they will write like this CO3. So this is the wrong way. Here symbol for the carbon is the capital letter C and symbol for the oxygen is the capital letter O. Okay. Here the charge of the calcium is +2 and this polyatomic ion -2. Again we have to do the crisscross and a formula is like this. What will happen here? +2 -2 cancel here. So CaCO3. Ca. Here why I am writing the small letter here? Because capital letter C and the small letter A, it is a symbolic representation for this calcium element, calcium atom. Okay. So here CaCO3 is the chemical formula for the calcium carbonate. Okay. Then move to the next one. Next question, that is the fifth one. All the students please complete your class work. Okay. The fifth question is like this. Give the names of the elements present in the following compounds. In the fourth question, we wrote about the chemical formulas. Here we have to name the element which is present in the given compounds. Okay. First one, that is big plant. It is also called as a calcium oxide. Okay. Second one, hydrogen bromide. Third one, baking powder. Potassium sulfate. Then calcium carbonate. Okay. Question is like this. Give the names of the elements. Here they have given the compounds. Okay. Quicklime, hydrogen bromide, baking powder, potassium sulfate, and calcium carbonate. Okay. We know that how we are going to write the chemical formula of the particular compound by using a symbol of the elements. Okay. So the type of the elements which are present in this compound. So that type of the elements we have to name them. We have to name those elements which are present in these compounds. Okay. First one, quicklime. It is also called as a. Oh, we are going to, what is the name of this compound? Calcium oxide. Okay. So just now in the fourth question we have learned about the calcium oxide, calcium carbonate. Okay. What is the symbolic representation for the calcium? Ca oxide O. Okay. So here elements present in this compound is calcium, and which is the other one? Oxygen. Okay. So quick line, that is a calcium oxide. Here, this is the chemical formula for the calcium oxide, and elements present in this compound, that is calcium. How many elements are there? Two types are there. That is the calcium, and another one is the oxygen. So the calcium, we have to write the name. They said that we have to write the name of the element. What is the name of the element present in this compound? One is the calcium, and another one is the oxygen. Okay. Move to the next one. Hydrogen, hydrogen bromide. Here, how we are going to write the chemical formula for the hydrogen bromide? Hydrogen, a symbolic representation, that is a H. And for the bromide, we are going to write the Br. Okay. So, here, elements present. How many types of atoms of the elements are present here? Two. That is the H and the Br. It is stand for the bromine. Okay. So hydrogen and it's very important to learn the elements, name of the elements and its symbol. Okay. When you come to know when you learn the symbol of the element, then only you can write the chemical formula and also the name of the elements which are present in the given examples. Okay. So what you have to do, you have to learn the symbols for the elements. Next one, third one. Baking soda. What is this baking soda? Washing soda. Baking soda. We are going to write the chemical formula for this baking soda is NaHCO3. Okay. Sodium bicarbonate. Okay. Here the type of the elements present is the sodium, hydrogen, carbon and oxygen. Okay. So here elements present in this compound. First one is the sodium. Symbol for the sodium is the Na. Then next element is the hydrogen. Symbol H. Third one is the carbon and last one oxygen. Okay. So here this is the chemical formula for the baking powder. Here the name of the elements which are present in this compound is sodium, hydrogen, carbon and oxygen. This compound is made up of four type of elements. Okay. Then potassium, sulfate, here chemical formula K2SO4 and elements present. Tell me how many types of atoms of the elements are present in this compound? Yes, this K stand for potassium. Okay, the sulfate we are going to write. We are going to use the sulfur and the oxygen. Okay, so here three type of elements of the atoms are present in this compound: potassium, sulfur, and oxygen. Okay, here first one is the potassium, second one sulfur, and third one oxygen. Then last one calcium carbonate. Okay, here CaCO3 is the chemical formula for the calcium carbonate and elements present in this compound, that is three types atoms of the elements are present here. One is the calcium, another one is the carbon, and the last one that is the oxygen. Okay. Then carbon and oxygen. So this is about the fifth question. Okay. Move to the next one. Here, yesterday I gave a brief introduction about the mole concept. Okay. Here, once again, I will explain you about the mole concept, because here the next question which is related to the mole. Okay. So we know that when we used to go to the market, we are going to use the word that is a dozen to purchase a fruits. That is a, for example, banana. Okay. So when we are going to take a 1 dozen of a banana, the number is fixed in that 1 dozen. Okay. Here is equal to 12. What is this? It is a number. Okay. So here mole 1 dozen is equal to 12 number like this. Here a mole is equal to, that is 6.022 into 10 to the power 23. Okay, so here the number, this is also a number of fixed number or constant number. It is a big number. That is here 10 to the power 23 means here after the 1 we are going to write the 23 0 here. Okay. So here a mole is a number. Here that is a constant number. It is a, what is that number? 6.022 into 10 to the power 23. Okay. So to measure here this dozen we are going to use to measure the mass of the objects. Okay. So in our day-to-day life, what we are going to do? We are going to measure the mass. That is in terms of a gram unit. That is gram, kilogram, milligram. Okay. So here the mole like this mole, this number 6.022 into 10 to the power 23, this number is used in the chemical reaction. Okay. So here what will happen in the chemical reaction? How we are going to obtain this chemical reaction? In the chemical reactions, many number of atoms or molecules are present. So to deal with the small atom, to deal with the small molecules, this number is introduced in the chemistry. Okay. Mole is a number and this number was introduced by a scientist that is called as Amedeo Avogadro, and this number is also called as a Avogadro number. Okay, which is represented by M naught. Here in our day-to-day life, what will happen? We are going to take up many things. Okay, so to measure the mass of the sum of the things, we are going to use the units, kilogram, gram, milligram. Okay, like this. But here in the chemistry, in the chemical reaction, what will happen? In the chemical reaction, many, that is the molecules and the atoms is going to take part in the chemical reactions. So to deal with these small atoms, okay, or the molecules, this number is used in the chemistry. Here, what is the use? What is the significance of this number? That is, what is the significance of this Avogadro number in the chemistry? Here, when we are going to talk about the atomic level, we know that atom is a tiny particle. Okay, so when we are going to talk with the that is the atomic level, if this, that we know that a gram is the unit which we are going to use to measure the mass of the objects, but this gram, this unit is not suitable for the atom or the molecules because it is a very small, but this unit, that is a gram unit, is a very big. It is not suitable for, it is not convenient to use this unit for the atom. So when we are going to talk about this atomic level, here this mole, this number is used to measure the mass of the atom. So here we are going to measure the mass of the atom in unified mass. That is, symbol stand for the, we are going to use the unit. Here the gram, it is a big unit which is not suitable. It which is which is not suitable to use this unit for the atom. So instead of that, what we are using, that is mass of the atom. How we are going to measure, in what is the unit, that is the unified mass, which stands, the symbol for the unified mass is U. Okay, so here 1 mole is equal to 6.022 into 10 to the power 23. So here 1 gram is equal to this unified mass. This is the interrelationship, that is the relationship between the gram and the unified mass. Here we know that a mole is a number. What it is? It's a simple number. It is a number. That is a, what is that number? 6.022 into 10 to the power 23. Okay. So this number is introduced by the Avogadro. This number is also called as a Avogadro number. Okay, and which is we are going to represent it by a N naught, and this is going to use, this we are going to use in the, this number we are going to use in the chemical reactions. Okay, so here let us see that is the relationship between the gram and the unified mass. Here 1 gram is equal to 6.022 into 10 to the power 23 U. This U is the unified mass. For example, I will show you here. Mass of one hydrogen is equal to, here the mass of the one hydrogen atom is equal to 1 U. Okay, here this is atom. For this atom, we are going to measure in which unit? We are going to use this unified mass, this U. Okay, so here the mass of the one hydrogen atom, but here mass of 6.022 into 10 to the power 23 in here in one hydrogen, we are going to measure it in the one unified mass, but in this number, that is in 1 mole, what we are going to write here? Here 6.022 into 10 to the power 23. Here this stands for the, here we know that this number is equal to 1 gram is equal to 6.022 into 10 to the power 23 U. So in place of this U, when we are going to write the gram, this is called as this value is also considered as the molar mass. See here, this is the atomic mass of a one hydrogen. Okay, so but in the 6.022 into 10 to the power hydrogen, how many grams of the molecules are present? That is 1 gram. What we have to do? We have to change only this unit. So instead of writing the unified mass, we have to write here gram. The same value we have to take. That is 1. Here also 1. But only the thing change is that we have to change this unit. That is the gram. This is also called as a molar mass. Okay. Here I will write a few examples. Elements like hydrogen and helium, carbon. Okay. Atomic mass of this element, that is hydrogen, atomic mass 1 U, helium 4U. This is the unit which we are going to use for to measure the mass of the atom. Okay, and carbon 12U, and here relative atomic mass. Here the elements hydrogen, helium, carbon, these are the elements, and the atomic mass of these elements, that is for the hydrogen 1 unified mass, helium 4 unified mass, carbon 12 unified mass. Okay, when we are going to write the relative atomic mass, what we have to do, we should not write this unified mass, that is we should not use 1. We have to write, for when we are going to write the relative atomic for the hydrogen atom, what we have to write? We have to write only 1. Here we should not write this unified mass. For helium we have to write 4, and for the carbon we have to write a 12. Okay, these terms are interrelated. Then next, gram atomic mass. See, dear students, gram atomic mass is also called as a molar mass of a given atom. Okay, so this is the atomic mass of the hydrogen, atomic mass of the helium, atomic mass of the carbon. When we are going to write the relative atomic mass, what we are going to do here? We are going to just remove this unit. Okay. Then when we are going to write the gram atomic mass is also called as a molar mass. This atomic mass, the atomic mass number, the relative, this value we have to take, that is a 1. Instead of this one, we have to use the G, that is a gram. Okay, then it is called as a that is the in front of this relative atomic mass. What we have to use? We have to use the gram. Okay, then it is going to call as a we are going to call it as a gram atomic mass. This is also called as a molar mass of a hydrogen atom. Okay, then what is the gram atomic mass of the helium? 4 gram. Okay. Then what is the gram atomic mass of the carbon? 12 gram. Only the thing is that we have to write the G in front of this number. Okay, this value. So atomic number, relative atomic mass, that is atomic mass, and the relative atomic mass, and a gram atomic mass. Okay, so here 1 gram, we know that this number, it is in 1 gram, what is the number or number of the particles present here? 6.022 into 10 to the power 23 U. Okay, so in the 4 gram, the same thing, this number is present, 6.022 into 10 to the power 23 U. Here 6.022 into 10 to the power 23 U. Okay, so like this, a gram and the unified mass are related. So here we are talking about the atomic mass. When we are going to take the molecules, okay. Here this is the hydrogen atom. What is this? Hydrogen atom. When we are going to write the hydrogen molecules, what is the molecules? It is made up of two or more atoms. Either it will be a same kind of atom or the different kind of atoms. Okay. Here H is stand for the hydrogen atom. H2 is going to stand for the hydrogen molecules. Okay. Like this. nitrogen atom. Here, when we are going to write the N2, this is a nitrogen molecules. Nitrogen molecule it is, okay. So here when we are going to take the when we are going to measure the mass of the molecular mass of hydrogen, nitrogen, here this relative atomic mass, here we have to write relative molecular mass. Why? Because we are talking about the molecule. Here the thing you have to remember that whether we are going to talking about the atom or the molecule. Here we are talking about the molecule. Here we have to write the molecular mass, and here this one is the relative molecular mass, and the next is the gram molecular mass. Okay, so 2 unified mass for the nitrogen 28 U, carbon dioxide here 44 U. Okay, and when we are going to write the relative molecular mass, what we have to do? We have to remove this U. Okay, so for the hydrogen relative atomic mass, that is 2. For the nitrogen 28. Here atom of the nitrogen, what is the value here? 14U. But here for the nitrogen molecules, 2 nitrogen atoms are there. 2 into 14, 28. So for the value of the nitrogen molecules, we are going to write here 28U. But when we are going to write the relative molecular mass, we should not write this U. Okay. So 2 for the hydrogen molecule, 28 for the nitrogen molecules, that is the relative molecular mass of the nitrogen, and relative molecular mass of the carbon dioxide is 44. Then last one, that is a gram molecular mass, is also called as a molar mass of given molecule. Here we should not write the atom here because we are talking about the molecule here. Okay. So what we have to do? The relative molecular mass, this value we have to write as it is. In front of that we have to write a G, that is gram. Then it will become a gram molecular mass or the molar mass. Gram molecular mass of the hydrogen is 2G, and gram molecular mass of the nitrogen is 28G, and gram molecular mass of the carbon dioxide is 44G. These values are also called as a molar mass of the hydrogen, molar mass of the nitrogen, molar mass of the carbon dioxide. Okay, when we are going to use the gram molecular mass, the another name for the gram molecular mass is that molar mass of the molecules, your molecules. Okay, so this is how the gram is related with the unified mass. And here in 1 mole, what is that number? Constant number, a fixed number, 6.022 into 10 to the power 23. This we are using in the chemical reaction. Okay, so dear students, let us continue in the next class, that is the 6th question. Okay, so this is about the mole concept. Okay, so based on this mode concept, we are going to solve a few examples, that is a few questions which are present in your exercise part. Okay. Let us continue in the next class. Thank you, students.